everyone and welcome. This is Vasco from the Angular University, and in this lesson we are going to build our first Angular 2 application from scratch. So let's get started. The first thing that we need to do is define our root component. Let's define a class named app. This will be the entry point of our application. We need to annotate it with the @component annotation. And inside the @component annotation, we need to pass in a JavaScript object that contains two mandatory properties. One is a selector, so this is a CSS selector that will define to which HTML elements in the page this component gets applied to. We're going to give an example of such a component in a second. The second mandatory property is the template property. We need to specify either a template or a template URL. We will see that in a future lesson. Right now, let's define an inline template, which simply prints a message to the screen saying hello world. How can we use this component that we just created? What does this look like in terms of HTML? If we see here the HTML of this page, we are going to add to this page a custom HTML element named app, which Angular will associate via the app selector to our component. And so it will replace the content of this custom app tag by the message hello world. And this is one of the most powerful features of Angular 2. We can create our own custom HTML elements. What we need to do now is to start our Angular 2 application. We need to bootstrap it, to use the framework's terminology. So to do that, we have several ways of doing it. The recommended way of doing it in development mode is to use the Platform Browser Dynamic Bootstrap module method. So what this takes is an Angular 2 module definition, which will be used to bootstrap the application. So what is an Angular 2 module? We are going to go into modules in detail later in this course. Right now, for us, it's enough to know that a module is a way of grouping related Angular 2 functionality, grouping related components, directives, pipes, and services in a single logical unit. Our application has one root module. Let's write it. So we just need to define a class that by convention should be called app module, and we are going to apply it the @ng-module annotation. Inside it, we are going to pass it a configuration object. In this configuration object, we need to define which components this module recognizes. And we are going to add in, of course, our app component, the root component of our application. We also should specify which is the entry point of the application, because we could have many components that are recognized by this module, but we haven't told Angular what is the entry point of our application. In this case, we are going to configure it via the bootstrap property, and we are going to say that our root component is the app component. So we pass in this module to our bootstrap call, and we should have a running application, right? Let's give it a try. If we now try this out, we can see that we have here an error in the console. Why is that? That's because we have not imported the browser module that contains all the core Angular 2 directives and much more. If you are developing a web application that is going to run in a browser, we should import the browser module. If we are running in other environments, such as, for example, native mobile, we would have another module that would replace the browser module. For the moment, let's include it and see what happens. If we now try this out, we can see that our first Angular 2 application is up and running. Summarize. Each Angular 2 application is a tree of components, and there is usually only one root component. We need to specify a root bootstrap module that we need to pass to our bootstrap function. This module will declare which components this application recognizes. What are the components that make up this application? What we do here is we can import them one by one in the declarations property, or we can import them together with directives and pipes and services as groups of related functionality named modules, and we can import modules in the imports property of the module declaration. If we are building a web application, we need to import browser module in our root component only. We should not import it elsewhere in the application. We need to tell the application what is its entry point. There could be several. Actually, notice that the bootstrap property is an array, but in most cases there is only one entry point for the application, the root component. What we're going to do now is we're going to write our first non-root component. We're going to add a visual component to our application. It's coming right up in the next lesson. Hello everyone, how's it going? It's Vasco from the Angular University, and in this lesson we are going to write our first Angular 2 component. Let's build a very simple widget, a search box widget, which contains an input box, and next to it we have a button to clear the input box. So let's get started. What we really want to do is we want to define an extra HTML element to the standard HTML elements that a page might have. We want to create a search-box HTML element, and we want to be able to use it in our application just like it was a normal HTML element. So how can we do this? We define an Angular 2 component. We define a class, let's name it simply searchbox. We are going to annotate it with the @component annotation. Again, this tells Angular that this is a component. Inside the configuration object, we are going to define a selector. The selector needs to match the HTML element name that we are going to use, in this case search-box. So by convention, the CSS selector that we apply here in a component should be an element selector. We should not, for example, use property selectors here. What we need to do also is to define a template for the component. What will the component look like visually on screen? A component might use other components. In this case, we are just going to add an input box to the component, and next to it we are going to add simply a clear button. And there we have it. We have a very simple component defined. In the upcoming lessons, we are going to see how to add behavior to this component. But right now we just want this HTML to be displayed on the screen in place of the search-box component HTML tag. To do that, what we can do is we can try to run the application like this. What will happen is that nothing will be displayed. This is because the application is not aware of the search-box component. Nowhere in our application we have configured this component. We need to do so by adding it to the module definition of our application. In this case, because we only have one component for the moment, we are simply going to add it directly in the declarations property of our root module. If we try to use this component again, if we reload the page, we can see that our component is now working. In the next few lessons, we are going to add behavior to this component. Namely, we are going to pass it inputs, and we are going to receive outputs out of it. So stay tuned because it's coming right up. Welcome to a lesson of the Angular University. In this lesson we are going to learn about component inputs. If you already know component inputs, in the end of this lesson I'm going to share a way of abbreviating certain situations where we are passing input to a component, so you might not be aware of that. So let's start with a simple example straight away. This is a search box component. It has an input box and a clear button. Now let's say that we want our placeholder text. We would like this not to be constant, but we would like to take it from a variable that is part of our search box component class. Let's do that. Let's define a variable. Let's call it text, and we are going to assign it the text that we want. Now, how do we output this to the component template? we're going to use the interpolation syntax that we are going to cover in more detail in a future lesson. Right now we are just going to output the value of a string into the template. This double curly brace expression is an interpolation expression, so the double curly brace is recognized by Angular and tells it that the content inside the double curly brace is an expression that Angular should evaluate by taking as context the component itself. So if we, inside double curly braces, we output text, that will be taken from the search box component. Let's try this out. If we now reload the page, we can see that the placeholder is type your search as expected. Now, we would like to take this one step further. We would like to make the placeholder text configurable by any other component that is using the search box component. For that, we need to make the variable text an input of the component, and we can do so by annotating it with the @input annotation. And notice the parentheses at the end of the annotation. Without this, the annotation will not work. Now, one thing, we don't want the input that is passed to the component to be named text. That's just an internal name for an internal variable. We want the input to be named placeholder, like the standard HTML attribute. So now, how do we use this input? How do we pass in an input to a component? So we go to the component that is using search box, in this case our root component, and we are going to pass it in a placeholder input variable. We do so with the angle brackets template syntax notation. This is the template syntax notation for inputs in Angular 2 components. We are going to pass into the input variable placeholder, we're going to pass it in a string. The goal is that this string overrides the default value of the text property inside the search box component. So let's try this out to see if this works. As we can see, we have custom placeholder displayed correctly as expected. So the input property is working. Now, you might think that this is a very common use case to pass a constant string as an input. Yes, it's true that in certain situations this might be a dynamic property, but in this case, let's say that it will always be constant. In that case, this syntax that we have here is slightly verbose. For this particular case, where we are passing in a constant string to an input property, we have an abbreviated notation syntax that we mentioned in the beginning of the lesson. If we remove the quotes around the strings and if we remove the square brackets, this will still work. So let's give it a try. As we can see, everything is still working and this looks like just a plain HTML attribute. This is much more readable. It actually looks like a plain HTML attribute, which is also more intuitive for someone looking at the template. What we're going to do now is we are going to add behavior to this component. We are going to, when the user clicks the clear button, we are going to clear the input box. So we are going to learn the template syntax for events in the next lesson, which is coming right up. Hello everyone and welcome. This is Vasco. Welcome to the Angular University. In this lesson, we are going to learn about component events and event emitters. So let's get started. What we're going to do here is we're going to take this simple component, which is the search box component, which has an input and a clear button. We're going to implement the clear button behavior. So what we want to do is whenever we type on the input search box, when we click clear, the clear button, the input box should be cleared. So how do we handle this? Let's use the events template syntax for this. So what we want to do here is in the element where the click occurs, so the button, we're going to add a click handler and we are going to use the rounded parentheses or normal parentheses for this. This is the template syntax for events in Angular 2, both browser events and custom events, as we will see in a moment. Now, inside the rounded braces, we're going to type the, in this case, browser event to which we want to respond to, in this case, the click event. On the right hand side, we are going to define how this event should be handled. In this case, we want to call the clear component method. Let's implement this method by simply adding a call to log to the console. Let's try this out. If we now type in something and we click the clear button, we can see that our statement is logged to the console as expected. Now let's talk about how could we implement the clear behavior. Well, one way to do it, let's do it first in plain JavaScript. So let's select using the Chrome DevTools. We're going to right click on the input box and we're going to inspect it in the HTML panel. If we now switch back to the console, the $0 variable contains the last element that was clicked while inspecting this on the DevTools. So in this case, $0 is the DOM element of the input box. How can we clear this? We can clear it by assigning it a value of an empty string, for example. So if we do $0.value equals empty string, this is an example of how to clear the input box. So let's implement this in Angular 2. Let's now implement the clear behavior. So what we want to do here is we want to introduce a new concept besides events. We want to introduce the concept of references. So we can assign a template reference using the hash character, and we are going to give it a name to the input box. We are going to call it hash input. So whenever inside the template we refer to input, we are referring to the DOM element of the input text box. So now we can pass it in as a parameter inside the clear method, for example. Now, what we can do inside the clear method is we simply assign it a value of an empty string, and this will clear the input box. Let's try this out. If we now type in the input box and we hit the clear button, we can see that the input box is being cleared as expected. Now we have seen how to use the template syntax for events. In an upcoming lesson, we're going to see how the same syntax can be applied to custom events. We will first learn how to externalize the templates of our components and how to apply CSS styles to our components. Then we are going to tie everything together in a more complex introduction to components example, where we are going to have multiple components interacting with each other and using custom events using event emitter. So stay tuned, all of this is coming right up in the next lesson. Hello everyone and welcome, this is Vasco from the Angular University, and in this lesson we are going to learn how to externalize component templates in an external file. We are going to learn the best practices recommended by the official style guide for that. So let's get started. We have here a very simple component with an inline template defined using the template property in the component annotation. Defining templates inline, it's usually okay when we are trying out something, or maybe if your component is a very small component. But in general, we really want to separate the template into an external HTML file. So let's do that. Let's extract the HTML template from the component and let's create an external file which has the same name as the component file itself, except it has a different HTML extension. We just copy paste inside this file the template itself, and now we just need to apply it to the component. To do so, we go back to the component file, and instead of using template, the inline template, we are going to use the template URL property. As we put the template in the same folder as the component itself, we just have to type in here the file name of the template. This will work just like this, transparently, if you are using, for example, the latest Angular CLI. If that's not the case, then you really have to give Angular some more information on how to find the template file. If you are using a CommonJS compatible module loader like, for example, System.js, you will have available at runtime a variable named module. You can take it and use module.id, pass it to the component via the module ID property, and Angular will know how to find the template. to avoid TypeScript errors, you need to declare the module variable. Again, if you are using the CLI, you don't need this module.id variable. So it's one of the many advantages of using the CLI. So this covers how to handle HTML templates in our components. Let's now see how can we add styles to a component and what is the big advantage of doing it the Angular 2 way. Stay tuned, it's coming right up. Welcome, this is Vasco from the Angular University, and in this lesson we are going to learn how to style Angular 2 components. We are going to learn what is the big advantage of styling components the Angular 2 way. We could always style a component by adding simply a link tag to our HTML page. That would work perfectly with Angular 2 without any problem. But Angular 2 introduces a new improved way of doing CSS. Let's have a look at it. The way that this works is in each component we can define styles that are specific to the component. So we have a styles property that takes on an array. This is an array of strings. Each string is just an extract of CSS, so let's just add some CSS to this component. If we add here some CSS as part of this styles array and we refresh the page, we can see that the CSS got applied to the component. But let's have a closer look to see how this was done. The styles were actually added as a style tag in the head of the page. We can see here that the styles are applied to the component, but notice this property with a randomly generated name that gets associated to the component. All the styles reference this attribute here. This means that these styles have a very high degree of specificity, because they all have an attribute in it. This causes these styles to take precedence over almost any style that you might want to apply in a page. Compared to the specificity of most commonly used libraries like styles in Bootstrap, etc., these styles would take precedence. So this mechanism is a way of partial style isolation. We can define styles that in the vast majority of cases will take precedence over any other style on the page. But the component is not really fully isolated from a style point of view. It's still inheriting, for example, fonts from the main page. If you are building an Angular 2 component, it's better to use the styles property to define the CSS of the component. This means that, for one, the styles of the component are guaranteed to not interfere with the styles in the remaining of the page, because they are based on this randomly generated property. Also, it's much less likely that styles on the page will override this style, meaning that the component will be reusable in a larger number of situations. We can also define CSS styles in external files in a very similar way to how we did it with templates. We simply create an external file which has the same name as the component file but a different extension, in this case CSS. What we're going to do is we are going to copy the CSS inside the file and we are going to add this file associating it to the component via the styles URLs property. Notice that this is an array, so you can pass in several CSS files in here. So we now have some basic notions of how to set up a component. We can define its template, we can define its styles, and we can define the component class. What we're going to do now is we are going to tie all these concepts together with the notion of inputs and outputs of components. We're going to build a more complex example where several components interact with each other. It's coming right up in the next lesson. Hello everyone and welcome! This is Vasco from the Angular University, and in this lesson we are going to go through a more complex example of how to build components. We are going to build multiple components and we are going to make them interact. We are going to build custom component events. So let's get started by doing a demo of the final result. So this is the final result. You have here a couple of components. One is a color picker where you can click in one of the red or blue sections and a color will be chosen. The color is applied to the title, pick a color, but it's also passed as an event to another component that is interested in receiving that event, which is the color previewer. So if we click in one or the other color, the color previewer will update its color accordingly. So let's get started by building this example. Let's start by building the color picker component. Let's start by defining a class, color picker, and we are going to define a selector, which is color-picker. We're going to define a template that for the moment has only some static HTML on it. So we are going to create a div with the class color picker, and we are going to add the two divs for the color samples. Let's now try this initial version of this component, which currently does not have behavior. We are going to add the color picker component to the list of declarations of the root module of our application, and we're going to use the new color-picker HTML element in the template of our main application. If we try this out, we can see that the template is being applied correctly. What we want to do now is to implement the color picker component. So we are going to add it a color variable, which contains the color that was just selected. We're going to make it an input of the component using the @input annotation. Next, what we want to do is we want to use this variable to color the title of the color picker. For this, we are going to use the ngStyle directive, and we will be covering this directive in detail in a future lesson, but right now we are simply going to use it to determine the color of the title. Here we pass to ngStyle a JavaScript object. It has one property named color. The value of that property is the value of the color variable of our component. Let's try this out to see if this is working. So if we pass into the color picker component, we pass it in a variable color with value red, we would expect the title to become red. Let's quickly try this out. So as we can see, everything is working as we would expect. Let's now implement the behavior part of color picker. So whenever we click in one of the divs, we want to emit an event saying which color was chosen. So how can we do that? The first thing that we need to do is we need to detect a click event in one of the divs. And we do so with the template syntax for events with normal braces. So we detect a click on a div, and we're going to call a component method named shoes. Now, we are going to pass it in the color that was chosen. We have here the two CSS colors that are available defined in this constants file. Let's then use these two constants to implement the shoes behavior. So what we're going to do is whenever shoes is triggered, we're going to pass in the color that was just chosen. Now, inside the choose method, what we're going to do is we are going to emit the chosen color as a custom event to the outside world, to any users of this component. So to do this, we need to create a component event emitter. We do that with the event emitter class. We create a new instance of it, and we are going to assign it to a variable named color output. In order to trigger a custom event, we just need to call emit on the event emitter and pass it in the value that we want to emit, which is the new color. There is one final thing that we need to keep in mind. To the users of this event, we don't want them to subscribe to the color output event. That's the name of an internal variable. We want the subscribers of this event to subscribe to the color event. And that's why we need to put color as a string inside the @output annotation. Let's now subscribe to the color event. So we do so by using the same syntax that we have used to subscribe to standard DOM events, such as click. When a new event occurs of type color, we are going to call a onColor component function, and we're going to pass it in the color that was just chosen. This value is available via the $event Angular2 template variable. If we use this variable, we can print to the console the color that was just chosen. Let's try this out. So if we click here in a color sample and we see what's in the console, we can see that the color was outputted as expected. Let's now implement a second behavior of this component interaction example, the reset button. So whenever we click this reset button, we want the color to be resetted, for example, to black. So how can we implement this? Let's start by implementing a reset functionality at the level of the color picker component. So if a reset publicly available method is called, we are going to emit the color black. Now, how can we use this in our main component? We can create a reference, a template reference to the color picker with hash picker. So because this reference is applied to an element which is not a standard DOM element, such as a div for example, the reference will become the Angular2 component itself. So we can use the reference on the click handler of reset to call directly the component reset method. If we now try this out, we can see that whenever we click on reset, black gets applied to the color picker as expected. Let's now implement the last component of this example, and we're going to see an interesting way of making components interact. Take a look at this. We're going to implement the color previewer component. This is a very simple component that takes as input one color, a color variable, and we are going to simply use that variable to output it to a text title. Like before, we are going to apply the color by using the ngStyle core directive. We now need to apply the color previewer component and add it to the module of our application in order to be able to use it in our application templates. Let's quickly try out this new component to see how it works. So if we add it to the template using the color-previewer HTML element, we can pass it in, for example, a constant color of red. Let's see if this is working. So if we try this out, we can see that the color previewer is working as expected. What we want to do now is we want to make the two components interact. So whenever a color is chosen in the picker, we want to apply it to the previewer. A first way of doing this, and we're going to see a better way in a second, first way of doing this is taking the color output that comes from the output event, and we're going to assign it to a variable, and then we pass on this variable as an input for the color previewer. There is actually a better and maybe more declarative way of doing this. Let's have a look. If instead of storing the output of the event in a local variable, we instead create a reference to the previewer using hash previewer, what we can do is we can pass in the output of the event of the picker directly to the previewer. With this, we no longer need the color variable actually, so we can remove it, and we have here a more declarative implementation. So you need to strike a balance here. There's more logic in the template, but at the same time we have not created variables that can be mutated and could be a potential source of errors. So depending on the concrete case, you might want to apply this technique or not. And so there we have it. This is the basis of Angular 2 components. By using a set of simple concepts like component inputs, outputs, custom events, template references, we are already in position to create a wide variety of Angular 2 components. Let's try this out with an exercise in the next lesson. Hello, how's it going? It's Vasco from the Angular University, and in this lesson we are going to learn how to build our own custom Angular 2 directive. It's coming right up. So you might have noticed while coding in plain HTML that there are certain attributes that we add to elements that add or remove existing functionality to those elements, such as, for example, the required attribute that marks an input field as mandatory in a form. In this lesson we are going to learn how to build such a custom directive, again extending the standard functionality of plain HTML with our own custom functionality. This is what Angular allows us to do. The custom attribute directive that we are about to create is the collapse on click directive. Whenever we apply it to an element on the page, that element, once it's clicked, will disappear from the screen. So This is just an example, and the directive can be applied to any element on the page, including to Angular 2 components. A directive in Angular is simply a plain JavaScript class annotated with the @directive decorator. In there, we're going to pass it a selector, and notice the square brackets. This means that the directive should be applied to any HTML element on the page that has a collapse on click attribute. It is a best practice in the case of attribute directives to always use attribute selectors instead of, for example, element selectors like we do so for the case of components. Please be sure to check the end of this section for the exercise, where we're going to present an implementation of collapsible that uses more features. Right now we are simply going to define a CSS selector that says the following: any collapsible section inside a collapsed element should not be displayed on the screen, so display none. Be sure to check the section on ngIf. So this directive will work in the following way. We need to detect clicks on the element on which the directive is applied to, and that is known as its host element, the directive's host element. In this case, it's this div with the CSS classes of card and card strong. Next, what we want to do is, whenever that click occurs, we want to add or remove a collapsed class to the host element, and that will trigger the appearance or disappearance of the collapsible panel. Let's see how to do this. Let's first create a isCollapsed private variable in the collapse on clicks directive, and what we're going to do is, whenever a click event occurs in the host element, so we are going to use the @hostListener decorator to detect events in the host element. Whenever a click occurs, we are going to toggle the value of the private variable isCollapsed, which has a default initial value of false. What we want to do now is add the collapsed CSS class to the host element, depending on the value of the isCollapsed private variable. For that, we are going to use the host binding decorator. The host binding decorator allows us to write to properties of the host element. So in this case, what we want to do is we want to set the property class.collapsed in case that the property isCollapsed of the directive is set to true. So let's now see our first custom directive in action for the first time. If we now inspect the HTML, we can see that, for example, when we click on the "this page section is collapsible" text, whenever we click on it, the CSS class collapsed is either added or removed from the host element where the directive was applied. As we can see, directives have the potential of giving us more reusable functionality compared to components. Any functionality that we add in a directive, we can add potentially to any component. But directives are really not that different from components. Let's have a look why in the next section. Hello, how's it going? Vasco here from the Angular University. In this lesson, we're going to learn how to do our first HTTP call in our lesson service. So, coming right up. Take a look at this version of lesson service. It's still retrieving the lessons data from a variable in memory. What we're going to do is we're going to fetch this data from the backend via an HTTP call, a GET call. For that, let's inject the standard HTTP Angular 2 service. So this is a service that comes together with Angular. We're going to use it to do a GET call using this.http.get. We pass in the URL that we want to hit on the servers, in this case /lessons, and let's have a look at the server. The server is just a simple Express server for testing purposes, for demo purposes. I will show you in an upcoming lesson how to set up such a server. Take a look. Once the server gets a GET, so get lessons, it's going to return a JSON object that contains the lessons data. Take a look, the lessons data is still the same data that we saw before, but right now it's going to be served by our backend. In order to get back the result from the backend, we need to subscribe to the output of the get method. The output of get is an RxJs Observable, and we are going to go in detail on what that is and how to use it. Right now, we are going to subscribe to the output of get, and we are going to pass it a function. So this function has one argument, lessons data, which is the data that came from the backend. And on the body of the function, we have only one line where we are going to take the result that came from the backend, so lessons data, and we're going to assign it to the service lessons variable. Notice that we are getting here an error, and this is because what we receive from the get call is not immediately what we send as response from the backend. What we get is a response object that has other information other than the data. So what we need to do is, using the map RxJs operator, we need to transform the response into only the data. So we do that by calling map and then response.json. This will transform the response into the output of response.json. And like that, in our subscriber method, we receive only the data, the lessons. Note that the HTTP service, like the lesson service, needs to be provided at the bootstrap call of the application so that it's available for dependency injection. So in this case, we are going to pass in HTTP providers to the bootstrap call. Without this, the HTTP service will not be available at runtime and you will get an error. Let's now see all of this in action. If we reload the application, we can see that all the data is still there, and if we open the network panel of our developer tools, we can see that an HTTP request was done and that we received the data from the backend. Next, what we're going to do is we're going to save some data to the server using Angular 2 HTTP and add that to our service. In the following lesson, coming right up. Hello everyone, how's it going? It's Vasco from the Angular University. In this lesson, we are going to set up the Angular 2 router, and we are going to avoid a couple of huge pitfalls from the beginning to give you an optimal Angular 2 router learning experience. It's coming right up. When setting up the router, the first thing that you want to define is your base path. You can do that using the HTML5 based HTML tag, and you should point it to the entry point of your application. So in this case, we are pointing to this particular folder. Most of the cases you will have a base of /, meaning it's the entry point of the server. In order to be able to use the router, the first thing that we need to do is to set it up in our application, because it's not included by default in Angular. So in order to do so, we need to go to the root module of our application, the app module, and we need to import the router module. But we should not simply import it. We should call this method for root and pass it in the router configuration. We are going to understand why this for root method is necessary in our lazy loading and shared modules lesson. Right now, this is the configuration that we need to get things started. When configuring the router, what we are doing is, depending on how the URL changes, certain sections of the page will display a certain content. We call those sections outlets. We are going to define here the primary outlet of the Angular 2 router. This means that in this section of the page, the content of this tag will be replaced by a certain component depending on the state of the URL. Which sections of the page correspond to which URLs? That's where the router configuration comes in. Let's set up our router configuration, so it's just an array of route objects and each one must define a path. So in this case, we want a certain component to display when we navigate to home, and we are going to display the home component. If we now try to access the root URL of our application, we're going to get an error, but this is normal because we only configure the path to home, not a path to the root folder. So we would think that if we add home to the URL and we hit refresh to reload the application, that this would work, but we get a different error. We get a 404 not found from the server. This is a very common situation for someone just starting with the router, and it's the main pitfall that we mentioned in the beginning of this lesson. How to fix this and what's going on exactly here. So what's going on is that when we modify the URL and we hit enter, we are actually triggering a full page reload from the server, so we are not modifying the URL using the history API. When we modify the URL manually and we hit enter, this is going to trigger a request to the server to load a file named home without an extension. This file does not exist, so we get back a 404. To avoid this problem, what we need to do is to configure our server so that any unmatched request will return the index.html file that contains our single page application. So /home should return us as the HTTP response the index.html file. Then Angular will bootstrap itself, the router will kick in, inspect the URL and take us to the home path. Let's apply this logic to our concrete case of our Node.js Express server. So we simply need to create an Express middleware that redirects us to the index.html file if the request was not matched by any of the previous routes that we configured. We will see in a second a better way of doing this, but let's try this out. So if we type in here an unmatched path, we get redirected to index.html, and this file contains our single page application. Our application kicks in and Angular takes over from there. But this situation is not ideal because we created a redirect. There's a better way, which is to configure the server to do, instead of a redirect, to return directly the index.html file. So if we do that in Express using response.sendFile, we are going to get back directly index.html, which is our single page application. Angular 2 kicks in, the router kicks in and notices I should be displaying /home. So it's going to look up the router configuration to see which component corresponds to /home. And it's going to display the home component. I really advise you to configure your server this way from the beginning in order to get a good development experience with the router. Otherwise you will just get 404 all the time. And with this you are all set up to further explore the router. We are going to explore child routes, auxiliary routes, and we are going to explain why does that contribute for a much better user experience and allows to more easily build much more modern and dynamic applications. So let's continue our deep dive in the router. Next up, router navigation. Hello everyone and welcome. This is Vasco from the Angular University, and in this lesson we are going to learn about Angular 2 child routes as part of our router course. So let's get started. Child routes allow us to navigate deeper into our application. The key thing to realize about child routes is that only one child route can be active at a time. And this might sound familiar to you. Take a look at these three top-level routes, so home, courses and lessons. Also, these three routes are only active one at a time. So we could also see our application as having one main entry route, let's say the empty path route, and that empty route has three child routes. Each can only be active once at a time, so this would be an alternative way of configuring our application. Let's try this new configuration. So as you can see, the application still works exactly as before. Let's now give a more common example of the use of a child route. Let's say for example the route courses. Typically we would want a child route of it to show the details of a given course. So in the URL we would type /courses/1 or 2, so we would type the ID of the course, something that uniquely identifies the course. Let's configure this. We can actually configure something similar to this scenario even without using child routes. So let's for example configure a route course. Notice that it's course and not courses. Course/:ID, and then we map it to course detail, to the course detail component. Let's try this out. If we now type /course/ and then a number, let's say that's the ID of a course, we can see that the course detail component is being displayed to the user. Another way of doing this configuration is via the use of child routes. So under the path courses, we typically have the root path where we have the list of courses, and then we have a child route with the detail of each course. Well, we only want either the summary route or the detail route to be active at each time, and never both. So this is the ideal scenario for using a child route. For this, let's make courses a componentless route. This means that the route is there for routing matching purposes, but the route itself does not instantiate a component. Now we are going to configure two child routes for the courses route. The empty path route, which corresponds to the courses component, the component that shows the list of courses, and the path with the ID of the course. This corresponds to the course detail. Again, only one of these two will be active at a given time. Let's try this out. If we reload the application and go to the path courses, we still have the courses list being loaded as expected. And now if we type manually in the URL courses / and then we give it an ID, we are going to be forwarded to the course detail route, like we expected. You might have noticed that this file is starting to contain a lot of routing configuration, so it's a best practice to split the routing configuration across multiple files. So let's create a new routing configuration file, courses router config, and we are going to copy it in the definition of all the routes that relate to courses. We are then going to import it in the main configuration file, and we are going to include it by using the array spread operator. We are getting deeper into routing, and this is only the beginning. So be sure to watch the following lessons for learning what is an auxiliary route. And we're going to do an exercise at the end of the course where we're going to build a complete dashboard. So stay tuned for the upcoming lessons. Hello everyone, and welcome to our Angular 2 Forms course. I'm Vasco from the Angular University, and in this lesson we are going to start by learning why do we need a full framework module for doing something apparently as simple as forms. Well, the main reason is forms are really not that simple. Forms can be a very complex part of our application, especially if there is a very large amount of fields, if the forms span several tabs, if there are editable parts of the form that can be edited via a dialog. Forms can be very complex. There can be a lot of business validation rules, interdependent validations depending on multiple fields of the form. You could have a whole tab in error. You could have multiple fields that are related in error. Angular 2 helps us deal with all that. It helps us extract the data from the form in a simplified way, so you will never have to write code that gets the data from the form and populates an object. That's done for you. Also, Angular 2 helps us dealing with validating the form, showing proper error messages to the user, clearly identifying which parts of the form need to be edited. That's the big added value of the forms module. Not every form is that complex. Take a look at this example where we are creating a lesson in a course. So we are going to put the title, the duration, and we're going to put the level, either beginning or advanced, and then we click on a button, create lesson. Now, what we want to do in this form is we want to extract the data that the user types in from the form. Let's start with that. That is called data binding. Let's configure this in a template-driven way. This is the closest that you can get in Angular 2 to the Angular 1 way, if you are familiar with Angular 1. If you are not familiar with Angular 1, don't worry, we are going to explain now data binding for this simple form. What we want to do here is we want to synchronize continuously the content of the form. We want to bind it to this lesson object. This lesson object is an instance of the lesson class, which has these properties. Take a look at the type annotations in the constructor. These are actually optional because we are specifying default values for each constructor parameter. So if we remove the type annotations, we still have type safety in this program. This TypeScript feature is known as type inference. In order to use Angular 2 forms, we need to set them up because they are not included by default in Angular. So in this case, we want to use template-driven forms. For that, we need to import, in this case, in our root module, we are going to import the forms module from the Angular/forms barrel. Now, what we want to do in this form before using ng-model is we want to turn off certain HTML5 features that are on by default, because we don't want HTML5 to be handling the validation of the form. We want Angular to do it. For that, we simply use the noValidate property in the form. We also don't need autocomplete, so I'm just going to turn it off. Let's also output the value of the lesson object to the screen using the JSON pipe so that we can see bidirectional binding in action. Now let's configure the title field to be bidirectionally bound to the lesson title property. For that, we're going to use ng-model and we're going to assign it lesson.title. This syntax here with the two parentheses is called the banana box syntax. If we try now this out and we start typing in the title lesson field, we're going to see that the lesson object is automatically kept in sync with the content of the input field with each key-up event. So this is the ng-model functionality in action. We don't need to code anything for doing data binding. It's done for us automatically. But that is only half the story of Angular 2 forms, data binding. Let's inspect the HTML. We have here several state classes: valid, or it could be invalid, touched, pristine. ng-model is also helping us validate this form, and we are going to see exactly how to do validation in the upcoming lessons. So stay tuned. Welcome, it's Vasco from the Angular University, and in this lesson we are going to start learning a completely different way of making Angular 2 forms, model-driven or reactive-driven forms. Why do we need two ways of doing forms? What's the difference? When to use each? Is coming right up. So first, let's take the same form that we did in the template-driven forms section. It's just a clean HTML form that you're looking at. We're going to write it in the model-driven way. The main difference towards template-driven forms is that in this case we are going to create the form and its controls programmatically, and then we're going to bind it to form elements, as opposed to using a set of directives to create implicitly behind the scenes the form and its controls for us. But enough about the theory. Let's see this in practice. In order to be able to use reactive forms, the first thing that we need to do is to import the reactive forms module into our application. In this case, we are going to import it into the root module of our demo application. Now let's create the form. Actually, let's use the form group directive to assign to this element an existing form, so we are not creating it in the template. I cannot stress this enough. So in this case, my form is the form associated to this HTML form. All the reactive form directives start with form, so we can see that they make a consistent group. Now, in our controller, let's define a variable myForm, which is of type form group. That represents the form. Now, let's start our program and let's see what happens here. We have not initialized the myForm variable, so we get an error. This is expected. Again, reactive form directives bind form elements to variables that we need to initialize ourselves programmatically. So in this case, we need to initialize myForm, and we're going to create a new form group instance. We're going to pass it in, for the moment, an empty configuration object. Let's try this out again. Now the error is fixed. We have created our first reactive form. Now let's add some controls to the form. Before we were doing that using ng-model. In this case, we are going to use the form control name directive, and we are going to assign to each form control a name like the directive says. Now, let's run this. What will happen? Try to guess. Of course, we get an error, because again, this directive is only binding to an existing control that we need to create ourselves. So, let's do that. Let's create 3 form controls, one for each input field, the title, the duration, and the description. We are going to create the form controls inside the configuration object that was passed on to the form itself. So, each property of this object, each property name, is the name of the control, and the value is the control itself that we're going to create with new form control, and we're going to pass to each control its initial value. Let's try this out. So as you can see, the form controls have been initialized with the initial value, and we have no errors on the console. So congratulations, you have created your first reactive form. Why is it called reactive? What's the point? What's the difference? We're going to start to understand that already in the next lesson, where we are going to go over validation in reactive forms. So stay tuned! Hello everybody and welcome, this is Vasco from the Angular University, and in this lesson we are going to learn how to build custom form control validators. We will start with model-driven forms, and you will be surprised at how simple it is. Let's take a look. A custom validator for a model-driven form is really just a plain function. It's as simple as that. Take a look. We're going to create a new validator. It's going to validate the duration field completely. So not only it will validate it to see if there are only numeric fields, but we can only have durations less than 10, let's say 10 minutes. In order to use the validator, we just need to pass it to the configuration of the form control. It's as simple as that. A custom validator function needs to follow certain conventions. It takes as input the form control itself, so we can access the value using control.value. The function can return several things. In this case, we are going to return either an object or null. So if the function does not find any error, it should return null. But if the function does detect an error, it can return an object which contains the errors that it found and some extra information. So we are going in this case to return an object which contains a validate duration object, and inside we are going to set the property valid to false. This property is mandatory to return. Notice here this const valid equals false. So this is the result of the validation itself. I'm setting it to false initially so that the validation gets triggered. I just want to make a quick test to see if the function is correctly set up. As you can see, if we test this as it is, the error is always being thrown. This is a good sign that the function is at least correctly set up. Now, let's implement the validation itself. We want to return a valid value if the control value exists, it's a valid numeric number, and it's smaller than 10. Let's give this a try to see if it's working. So if we type valid numeric values but that are larger than 10, we still get an error. Let's try with a couple of values. So values below 10, they are marked as correct. And if we try to type non-numeric characters, we still get an error. So as we can see, adding custom validation to a model-driven form is really very simple. Template-driven forms has a bit more to it, but we're going to provide you a nice recipe for doing it. Then, learning the differences between the two modes, when to use each, and our exercise that it's coming right up.